Okay, so here for this demo, we're in a Windows 10 64-bit machine, version 1903, as you can see here. And now, since we've never ran AquaWrench here, we first need to load our vulnerable driver that we're going to use. So we can just give it the -L flag. And you can see it loads our driver here. I just want to mention briefly that in this demo, I'm blanking out like the driver name, right? The original checksum and original MD5. I'm not doing that because I don't want to show you what it is. But since we're not releasing this tool publicly, and I have to maintain it, I'd rather not get the driver burned if I don't have to, right? Okay. So our driver loads here, and we can see driver load was a success, right? So now we should be able to use it to do whatever we want. So in a first instance, what we'll look at is here at all of the protected processes. So you can see kind of what we saw on the slide, right? In this case, the protection status of this process here at PID 2288 is the type is light, right? Protected light, and the signer is anti-malware, just like the example on our slide. And if we look at this process, this is Microsoft Defender's anti-malware service, right? Which makes sense. And you can see other types here, right? Light Windows, light WinTCB, full Win system. So you can kind of see the different types of levels that we talked about briefly. So what we're going to do here is we're going to take this PID and we're going to change its protected status so that it is none, just like any other normal process. So to do that, we can just have a quick look at the options for AquaWrench. So these are the ones we're talking about, right? Protect takes a PID, 2288 in our case, and then a protected type, PT, and a protected signer, PS. So for us, it's quite simple, 2288. Let me just double check that, 2288, okay. A PT, a protected type, is none, and a protected signer of none as well. And then you can kind of see that AquaWrench finds out where the eProcess virtual address is, right here in this case, and it does a check for the OS build. So all the functionality in AquaWrench pretty much is gated behind a detailed version check, right? That's to make sure that we never run into a scenario where AquaWrench tries to do something in the kernel where that scenario has not been tested on that actual version. And you can see that in this case, it finds that PS protection structure, like on the slide, protect light, anti-malware, and it goes in and it changes it to none and none, right? Now, if we look here, it hasn't changed. That's just because Process Hacker is not updating that value. So if we just restart Process Hacker here, we can see that this process is no longer in that list, right? So if we sort 2288, you can see that status is now gone, right? And that means that we can actually terminate this if we want now, right? Something we couldn't do before. So that's one option. Something else we can do, as I mentioned, is like, let's say we take Notepad and let's note down the PID. So the PID is 7652. What we can do is set a different protection status for Notepad if we wanted to. Okay, so let's have another look at the options. So P is this, and the protected type, right? You can see this hierarchy we were talking about. So let's go here for protected. Okay, and the PS, or the protected signer. Here you can see where anti-malware fits in on this scale of ascending order of protection. So we can do like WinTCB if we want, why not? Okay, and then we run that, and you can see it goes from none to protected WinTCB. Now if we relaunch this, we can see, look, our Notepad process is here, enjoying one of the highest protections that exist, a highest combination of protections that exist on Windows. Okay, so let's close this. I just want to give one final example. So again, we'll launch Notepad here and note down its PID. So 4480 in this case. Okay, and then we'll have a look at one of the other protected processes, CSRSS, for instance. So if we look at that, we can see that this process is protected light, right? Protected light, and the signer is WinTCB. Now, there should be no way for us to open a handle to this process or duplicate a handle from this process, but with AquaWrench, we can do all of that. So if we again have a quick look at the options, we can see there is this duplicate option, right? Source PID to duplicate from, target PID to duplicate to, and a handle to duplicate from the source to the target, right? If we don't specify that handle, then it will open a process handle to that process. So I think we can just kind of open a process handle. Why not? So here we specify DS, duplicate source. In this case is this. No, that's the target, right? Duplicate target, and the source is CSRSS, which is PID 500. Okay. Okay, so we do some tricks here, like the details are not totally important, but essentially we have using some NT functions like NT-duplicate object, we've essentially put a handle into Notepad for whatever resource that we wanted access to. Okay, so if we now have a look at Notepad and we look at the handles, we're already at the handles. We can see here there is a process handle to CSRSS, which has a full control as granted access, right? Something that should never be possible. Now, even though I didn't demonstrate it, what we can do also is duplicate any handles that exist inside one of these processes. So if there was some kind of file or directory object or some kind of key you wanted access to that some other process has access to, you could say, I want this registry key access, for instance. So you could specify this handle, and AquaWrench would go and duplicate that handle into whatever target process that you want. Okay, I think that covers it for demo 1.